Hi, my name is Michael Jones and I'm with Keysight Technologies. I'm here to show you how we can scale AI RAN, but I'm also here specifically to show you an interesting use case for AI PHY, specifically the case of channel estimation. So in just a moment, I'll explain channel estimation and what we're doing, but this is part of an overall AI model lifecycle approach. The AI model lifecycle is not new, but how it applies to AI RAN is. We can do data generation using digital twins, but we can also do data generation using instrumentation on the workbench. And this is what we'll be doing with our presentation today. Here I'm showing two work pipelines. The first pipeline is how we're going to generate data for the problem of channel estimation. Channel estimation is very important. It allows the system to understand, based on received signals, how to compensate for channel conditions like noise, interference, and other line-of-sight and non-line-of-sight effects. We do this by generating a signal in our function generator, sending this into one of our tools that is a channel emulator called Propagation Simulator, which is the best tool in the industry for doing channel model creation. After we've impaired our frame, we're going to send this analog signal to our radio unit, or RU. Here we've partnered with Analog Devices. From there we send it to our Open RAN Studio. This is a lo-fi instrument that allows us to extract the INQ samples of the impaired uplink signal. At this point in my process, in my pipeline, I have two key pieces of information. I have an impaired signal and I have a channel impulse response. Those two things together are what I need to solve the challenge of channel estimation. Using a tool that supports orchestration and automation, I can use this same pipeline hundreds or thousands of times to generate lots of samples for my data set. The first thing that I want to do is use my product here, AI Development Platform, to store my data sets. I can store these data sets and I have access to detailed visualizations that help me understand the type of training data I'll be training my AI model with. These are some examples of the big data approach we have to data exploration. We have access to a workspace that allows us to introduce our models that are untrained to our data sets and perform training. After training, we're going to go back and register our trained model in this model registry. The next step is to do things like analysis of our training and analysis of our learning. Here we can do detailed analysis of not only the data that we've collected, but whether or not the model is performing poorly in its learning or how the model has performed well in its learning. In this example, visually, we can see by the solid line that the model has generalized successfully. In order to complete our process, we move back to our second pipeline where we do channel estimation using normal mathematical models. We'll get a bit level error rate from that shows how well the DU was able to compensate for uplink conditions. I then introduce my newly trained model. I can run my test again and see the reduction in my bit level error rate. The reason why this is important is the AI model must perform with low latency and high accuracy in order to be better than the traditional way we've done channel estimation. We enjoy skeptics here at Keysight because skeptics are the reason why we make test and measurement equipment. And in this example, we can help you determine if AI PHY is right for you. Thank you.